Okay, folks, thank you very much for joining us today. I won't keep you much longer. You may have some other attendees coming on board here, but we'll get started. First of all, thank you again for stopping by. I wanted to today we're going to be talking about CHP and our work in New York and some other regions as well. And obviously, what I'd like to do, two things I want to mention. I'll certainly include my contact information at the conclusion of this presentation. There's a lot of information, not enough time to get to everything. They shut off the mics and turn off the lights at about 30 minutes. So I'll try to be as efficient as I can, but I'm sure there'll be additional questions. So certainly reach out with any questions after the event. And I also wanted to mention, I will be talking a little bit about CHP and how it affects LL97 requirements and exposure. But I do have a colleague, Michael, at 3:15 tomorrow. He'll be doing a presentation more related to that. So if you guys do have questions regarding that, I would certainly encourage everyone to attend that session as well. And gather a little bit more information of how it all ties in. So thank you again for coming. My name is Eddie Machado. I am the business development manager for Dalkia Aegis, and I'll get right into it. So let's see. So first, I'd like to talk a little bit about who we are, who Dalkia Aegis is. Also about our micro CHP products, primarily in the 1 megawatt size or less, which has been our foundational products throughout our history. I also want to talk a little bit about CHP Plus product, which is a combination of CHP as well as a boiler system, and a little bit also about how we monitor as well as how we maintain the systems that we deploy. And if there's time at the end of the session, we can certainly talk about some case studies as well. So certainly if there are questions, I would advise to put them on the chat. Perhaps there'll be some time at the end to open up the lines for some questions as well. So I'll try to go as fast as I can and not be too fast. So here we go. So as far as Dalkia Aegis, we have been around since 1985, and our two main goals obviously have been to reduce energy costs either through energy conservation or on-site power production, and the other is really to reduce carbon footprint. So that has been the foundational structure of how we've been operating, what our expertise is since 1985. So about 3 or so years ago is when things changed a bit, when we were merged with EDF Group, which is an $80 billion European utility company, and Dalkia, and formed a couple USA contingencies. And what that has done for us is really given us more capabilities as it relates to on-site power in combination with CHP and how to deploy those assets. So we'll talk a little bit about that as well. And as far as the integration of CHP and other renewables, obviously we have the capabilities now of combining CHP with solar as well as battery and backup, different technologies relating to building out automation and controls, LED lighting, refrigeration and HVAC, as well as EV charging and even street lighting, for example. So there's definitely capabilities relating to that, as well as microgrid applications. But today we're focused on what our core competency is, and where our experiences really have the most foundational effect, which is CHP and cogeneration. So we'll talk a little bit about that. So most people that I talk to, either they know CHP in and out, they know a little bit about it, or they know nothing about it. So, cogeneration is really the simultaneous production of both electricity and usable heat through one energy source. So what we're talking about is one fuel source input for two forms of energy output, which obviously include electricity and heat. And that is essentially what we're talking about when it comes to cogeneration or combined heat and power, or CHP, as most of us call it in the industry. So as far as advantages, what we believe differentiates us from those that are in the space is really one point and one source of accountability from start to finish as it relates to cogeneration. So the first step in our process is obviously to work with those individuals who are either advising facilities management and decision makers, or those directly involved in the energy decisions for their facilities. And we really start with a full financial grade energy analysis by looking at the utility building and assessing exactly what sort of consumption exists in any facility, so that we can talk about what sort of on-site assets can be deployed and utilized in the most effective and efficient way. So that is something that we do. This is a financial grade analysis that can be utilized for financial purposes, as far as loans and other things as well. And this also can be insurance backed. So you have a certain level of guaranteed savings that can be realized through the financial analysis. And as far as the financial assistance, obviously we work with our clients to help them both in terms of assessing different incentives that exist out there, as well as tax credits and incentives that exist, so that the financial analysis that is done takes into account the overall cost of what it would be to implement this sort of strategy. And as far as designing and engineering, we have a full in-house staff of folks that have been doing this for 20 plus years. And we're designing and engineering the systems ourselves in terms of implementation. And of course, we're doing all the manufacturing at headquarters, in our headquarters in Massachusetts. And then we manage the full installation process from start to finish. And then after everything is up and running is when we will do a full monitoring of the system 24/7. And we'll talk a little bit about what that consists of in the latter slides as well. And then also how we go about maintaining our systems and keeping them running for 20 plus years. That is, again, what we believe the advantage is in terms of having everything under one umbrella and providing one source of accountability throughout the entire process. So now we get into what's the difference between having cogeneration and not having cogeneration, and as it relates to efficiencies between a power plant and the cogeneration efficiency. So as you can see here, for every 100 units of fuel that is utilized to generate electricity, you're going to get about 30 units of electricity delivered from a power plant application. And once you have cogeneration as part of that equation, you are still getting that 30 units of electricity, and now you are capturing the heat that's the CHP is generating. So you're talking about 55 units of heat, which gives you that 85% efficiency. So this goes, there's obviously a lot of benefits here, and we can talk about the LL97 exposure. And this is a primary reason why there is certain benefits as it relates to that. So let's talk about those benefits. Obviously, you're going to reduce your electric costs. Anytime you implement a CHP system, your returns are going to be in the 3 to 6 or 7 year range. Obviously, you're going to have resiliency, 24/7 monitoring capabilities and operations. And you obviously have backup power availability. We do have obviously units that have those capabilities. Obviously, you generally don't get a 3-year return on something like this based on the interconnections and added complexity, but you still are getting a great return on investment. And as far as other benefits, obviously you have reduction in emissions, carbon footprint. You have the efficiency there, 85 versus 35 efficiency. And of course, you have better ways to reduce your local law exposure, and we obviously show that through the analysis, both as things change over the course of implementation and how that's going to help to reduce those fees. So typical savings, you're really looking at between 15 and 55% reduction in your utility costs, and that is net net of the maintenance costs associated with keeping the unit running. Typical return on investment, as I mentioned, is between 3 and 7 years, and then you have carbon foot reduction of 55%. Now, in terms of some of the markets where cogeneration makes a lot of sense in the micro CHP space, you're really talking about multi-unit residential buildings, obviously healthcare, where you have a need for resiliency, and you also have 24/7 operations. We do a lot of work with recreational facilities as well, gyms and spas and the like. Hospitality, as we know, has been hit a little bit with COVID and occupancy, but certainly as they go back up and running, one of the main things that they're concerned about is obviously the cost of energy and how a system like this can really help to reduce their exposure and long term help them get a investment, a return on that investment. And education, obviously K through 12 is a big market for us. We're getting more and more involved in the higher education space as it relates to microgrids and off-grid capabilities. And then obviously specialized markets like breweries and other applications where you have higher therm requirements. Military is also pretty big for us in terms of resilience, like the healthcare that I described, as well as the pharmaceutical space. So CHP applications are really great for this sort of environment, where you certainly get the return on investment and you get the types of savings and carbon reduction that I mentioned before. Now, in terms of looking at cogeneration and certainly looking at what an ideal candidate would be and what the sweet spot is, you're really talking about buildings that are heated by hot water, right? So the more thermal loads you have, the more electric production you're going to realize by having that 2-for-1 exchange, as I mentioned. You're looking at about 12 to 1,500 therms of gas and about 25,000 kWh per month is where you need to be to start seeing that kind of savings. And generally speaking, you're looking at 80 plus apartment units in a healthcare setting. Obviously, 80 plus beds or residents is your typical ideal candidate, where the numbers generally work quite well. And then obviously, if it's a centrally metered type of building, then obviously you have a tie-in where you can obviously connect. The connections are much easier, and you can obviously deploy that power through that meter. And any market that has the higher rates, electric rates, that's where you're going to get the better, larger arbitrage between obviously the different fuel costs, as well as that 2-for-1 exchange, where you're going to get those higher savings capabilities. And of course, if you're dealing with the recreational facilities that have the pools and the spas and the like, you're going to have a higher thermal load thresholds, like the breweries, for example, where CHP is going to be a really good application, especially in the micro CHP side. So again, this is a quick map of it's an older map, but you can see anything that you see here that's in orange, yellow, green, or light blue is where where CHP is going to make the most sense, right? Where you have the higher costs that's going to help generate the kind of returns that a system can really help to generate. And then this is the example of what a New York City installation map consists of. Now, in terms of footprint, we have been, as I mentioned, in the market since '85. We've deployed over 1,000 of these systems. Our major footprint is really DC to Maine. We've done some projects in the upper Midwest and the West Coast, but I would say that over half of our systems are in New York City. So we certainly understand the market, the challenges, as well as the ongoing changes, and how this type of technology and platform can really help those that are managing these facilities to reduce their costs and have positive cash flow relating to that. So this is a little bit, just a brief little slide about our products in the micro CHP side of things. Obviously, sizes ranging from 35 kWs to 75 to 100 kWs, which can be stacked for larger applications. Some that have backup capabilities. Obviously, these are all EPA certified units. And just to give you a sense of aesthetically what they look like, and give you that exposure as well. And this gives you an internal view. Now, if there's anyone interested in a little bit more information about this, I can certainly send you some more in-depth specs on this. But everything that you're seeing here in red is really where you have the heat recovery. That's where you're going to get the temperatures needed for obviously the heating, as well as the cooling elements needed to maximize the unit. But this is what it looks like on the inside. And this is just some technical requirements to give you a sense again of the sizing of the thermal outputs. Obviously, they're all operating. They can operate all on low gas pressure, and then you have the consumptions of therms. But one thing that to point out, and something that we hear about all the time, is the concern about the noise and the sound quality of these units. And what I can tell you, between 56 and 70 dBs, you're really talking about the sound of a high-end dishwasher. So these are quite quiet. They're probably the quietest item on in the mechanical room. But those that have experience with CHP and they're exposed to some of the older units that are 20 years old or more, this is hard to believe for them, because those units can be quite loud. So something that I wanted to point out that I get asked quite a lot in terms of the sound, the way that works. So here we're talking really about CHP Code Generation and how it compares as it relates to resiliency. So we're comparing obviously battery storage and biogas, CHP, solar, wind, as well as standby generators, and with all of the different vulnerabilities that exists out there, especially now with the changes in weather patterns and all of the different things that we are seeing in terms of the elevation. What you can see here is that in terms of a resilient application, you're gonna see that natural gas CHP is going to provide the best outcomes when it comes to resiliency. And that's why, as I mentioned again, why we are doing a lot of work in the healthcare space, a lot of work in the military space. It is for this particular reason. So this is one example of that. And we talked a little bit about our CHP Plus applications early on, which is really a skidded combination of the CHP units. We're talking about a combination of boilers, as well as obviously the piping. You're talking about the heat exchangers, the load modules, the metering. Everything is compacted into one, right? These things can be, they're all obviously manufactured and put together at our headquarters. So what this means for the end user is that obviously the time of installation gets cut dramatically. The cost of installation is also reduced, because they're easy to obviously bring to a facility and put them together, more or less like a Lego set, where everything can be put together quite easily. So that is one example of that application. And here you have another example. This actually was a picture taken from an event that we did pre-COVID, back when we did these things live, right? So that's the front of a unit. That's an example here. And then here you have the very back of the unit, again, combining all three skids into one and making that either an indoor or an outdoor application. So there's different ways to manage that process. Now, this is a little bit about the specs relating to the CHP Plus product specifications. Certainly can send that out to anyone who has an interest in this to speak further about it as well. And then here we talk a little bit about our monitoring capabilities, and this is a live monitoring web view. We can see our units that are deployed in real time, and obviously we can see everything that's happening to the units in terms of the temperatures, how the units are communicating with the infrastructure and other thermal connections, temperatures. We're able to see things in real time. We're also able to make adjustments to the system so we can get the most power production, as well as handle preemptive maintenance on a remote basis, as well as identify problems as they happen, which allows us to handle a lot of the maintenance side on a very effective basis, either same day or next day. So in terms of keeping these units up and running, it's something where we take a lot of pride in. And in fact, when we do the analysis, we account for a 5% downtime, which obviously includes regular scheduled maintenance, as well as any unscheduled maintenance that our monitoring station can identify, detect, and obviously take care of. And we obviously have individuals in the area that can, wherever we have our units deployed, we have the staff needed to make sure that these units are taken care of on a regular basis. So this is a little bit about our maintenance. Obviously, we do daily performance reviews on each of our units. We handle the scheduled and unscheduled maintenance, same day, next day service, as I mentioned, 24/7 monitoring of these systems. And obviously the maintenance part of our process, covers everything in that suite, bumper to bumper. So it's a headache-free type of application where the end user is aware that if anything happens, we're there to support them and making sure that these units are operating at full capacity. So talk to you guys a little bit about some examples of some case studies. I have 3 here, all in the different end user profiles that I had mentioned before. Here's one in Brooklyn, New York, where we put in 2 100 kW units with the backup capabilities, costs of about $1 million or so. After incentives, it reduced it to $660. If we looked at the energy analysis, the gross savings, you're talking about $243,000. Obviously, with the maintenance program, brings you down to an annual savings, a net savings of $214,000, with a simple payback of about a 3.1 year return on investment. And as far as what our systems captured for this end user, you're talking about 68% of the electricity that the building required, as well as 31% of the heat that the building required. So certainly help to not only lower costs, lower the obviously the reliance on other sources of electricity and so forth. So that's one example. And then here we have a healthcare facility where we installed 2 units, 75 kWs each. We were able to provide 70% of this facility's electric needs at a savings of about $100,000 a year in net savings to them. And the third example, and we talked a little bit about the hotel industry. This is one unit where this was 75 kWs was the one unit that we installed. And we provided 30%, a little bit over 30% of the electric demands of the facility at an annual net savings, a little over 110,000. So that's just 3 examples of 3 case studies. And there are, we are very creative. As you can see here, these are some outdoor applications. And if you look to the top right, you can't even see where the cogen units are hidden. So there are ways to do these in a way that aesthetically is aesthetically pleasing. But if you notice, everything's tied in. All the controls and load modules, it's all compacted and much easier to manage, monitor, maintain, and obviously those that are working within the facilities, they certainly like these types of applications. So that's more of the outside the box view of some of the things that we have certainly done. And as far as next steps in our process, as we talked about, if there are opportunities where you are either managing facilities or advising your clients in terms of what they should do as it relates to on-site power, cogeneration, what we do is we look at the utility information, we do that analysis, that initial analysis, we go on-site to take a look and see exactly how some of these assets can be deployed. We then conduct the financial grade analysis, as we talked about. We design the system, and we provide options, whether it be for a direct purchase of those systems, where the end user can obviously realize the long-term savings, or looking at different financial options through power purchase agreements, for example, that we administer ourselves as well. So I have my contact information here. I think we made it just in the nick of time. I have some comments here in the chat, which I'll take a look at. But if anyone has any questions, I'm happy to answer as well. I think everyone may be muted. Let me see here. Okay. Any questions? If you for whatever reason, if you can't and you want to send on the chat, I'm happy to answer here. One of the questions I'm seeing here relates to garages as well as office space as it relates to cogeneration and on-site power. What we have found is that the application works more so if you have large needs for heat and hot water. So in the multi-unit residential space is where you're going to have individuals that are constantly using heat and hot water. In an office environment, not as much. So those applications generally don't have the same return on investment, at least not in that 3 to 7 year range. It certainly can work in conjunction with other on-site power capabilities. So we can certainly look at it. Also depends on, how large the facilities are, if they have other thermal needs relating to both hot water as well as cooling that can be offset through the use of cogeneration. So it certainly can be an application. We've done some creative things in terms of, ideal candidates that didn't seem like they were the sweet spot, but after evaluating their consumptions and their infrastructure, we were able to determine that, it certainly can be the appropriate application. Okay, any other questions? All right, folks. Well, you have you have my contact information here. I really appreciate your time. And they're going to cut the mic off very soon. So have a wonderful rest of your afternoon. And I'm here to help with any questions moving forward. So thank you so much.